Docker is everywhere today, but containers were not invented by Docker. I was working with similar concepts long before Docker existed. For example, Solaris zones and FreeBSD jails. So in this video, I'm not going to explain what a container is. Instead, I want to show you why I use Docker for my own production platform today. And for me, it mainly comes down to three things: isolation, a smaller attack surface, and reproducible deployments. The basic idea of isolating processes and applications is much older than Docker. Solaris, for example, introduced Solaris zones. FreeBSD has had jails for many years. So Docker did not invent containerization. What Docker did extremely well, in my opinion, was something different. It made containers standardized, portable, and easy to integrate into modern development and deployment workflows. Images, registries, networks, volumes, and automated deployments. Together, they form a very practical ecosystem, and that is exactly what I need for my platform. My platform is not a single application. It consists of several components: an Angular front-end, a Spring Boot back-end, Keycloak for authentication and authorization, PostgreSQL databases, and Traefik as the reverse proxy. I do not want to install all of these components directly on the host operating system. Instead, they run separately in containers. That means my Spring Boot service does not need to care about how PostgreSQL was installed on the host. Keycloak does not depend on a manually maintained Java installation on the server. And the dependencies required by different applications are much less likely to interfere with each other. Each service gets a clearly defined environment. That makes the overall system easier to understand, easier to maintain, and easier to deploy. One of the most important aspects for me is networking. Just because a service is running inside a container does not mean that service has to be reachable from the internet. With Docker, I can define dedicated networks and control which services are able to communicate with each other. Take PostgreSQL as an example. My database does not need to be reachable from the public internet at all. The backend needs to communicate with it. But a user on the internet? Of course not. So there is no reason for me to publish PostgreSQL port 5432 to the outside world. The same principle applies to other internal components. They can communicate inside the container infrastructure without being directly exposed to the internet. This allows me to significantly reduce the externally reachable attack surface of the platform. Ideally, there should be only a small number of entry points into the system. For a web platform, those are typically HTTP and HTTPS, in other words, ports 80 and 443. In my architecture, Traefik sits in front of the application. Traefik receives incoming requests and routes them to the appropriate service inside the container infrastructure. The databases and other internal services, therefore, do not need to be directly accessible from the internet, and that is an important security aspect for me. Not because Docker automatically makes a container secure, it does not. The advantage is that Docker allows me to design the architecture so that only the services that actually need to be exposed are exposed. This distinction is important. Just because something runs inside a Docker container does not automatically make it secure. And a container is not the same thing as a virtual machine. Containers normally share the kernel of the host operating system, so running containers securely still requires additional measures. That includes keeping images up to date, using small and well-maintained images, running processes with appropriate user permissions, managing secrets securely, performing regular security scans, and hardening and updating the host operating system. Docker is not a replacement for security, but it gives me useful tools for separating services and controlling how those services are exposed. And this is the key point. Docker itself is not the security architecture. The architecture is the security. The second major advantage for me is reproducibility. I do not want to log into my production server and manually install packages. Which Java version was installed? Which library version was used? Which configuration file did somebody change 6 months ago? That is exactly the kind of server environment I want to avoid. Instead, I define my application through a Docker image. That image is built. It is tested. It can be scanned for security vulnerabilities, and then that exact artifact can be deployed. The container image therefore becomes a standardized and reproducible deployment artifact. I know what I built, I know what I tested, and I know what I deployed. And this is where Docker fits directly into my CI/CD pipeline. When I commit new code, that code does not simply end up on my production server. My Jenkins pipeline controls the process. The source code is built. Automated tests are executed. Quality and security checks are performed. After those checks succeed, a Docker image can be created, and that exact image can then be deployed. The simplified pipeline looks like this: source code, build, tests, quality and security checks, Docker image, deployment. This is one of the main reasons Docker fits so well into my architecture. It gives me a clean boundary between building software and running software. The production server does not need to become a manually maintained development environment. It runs the artifact that has already gone through my pipeline. Docker is not interesting to me because containers are some completely new idea. I already knew the concept of isolation from technologies such as Solaris zones and FreeBSD jails. For me, the important part is the complete package. Docker gives me clean separation between services, defined internal networks, fewer unnecessarily exposed ports, reproducible images, strong integration with my CI/CD pipeline, and a clearly defined deployment process. That is why I use Docker for my platform today. Docker is only one building block in my architecture. In the other videos in this series, I explain why I use Angular, Spring Boot, Keycloak, and Jenkins, and how these components work together. And that is really what this series is about. It is not about presenting individual technologies in isolation. It is about showing how these technologies come together, step by step, to create a production-ready platform. Isolation, a smaller attack surface, reproducible deployments. That is why Docker is part of my architecture.